Okay, sample problem 1.5. Determine the number of significant figures in the following measurements. So we have a bunch of measurements here. Let's take them one by one. So the first thing to say is that any number between 1 and 9 is called significant. Now, when we use the word significant, really what we mean is we have confidence in that value. Meaning that if I write the number 17, I understand that this is 10, so it's a 1 in the tens column, and it's a 7 in the ones column. And that if I said there's 17 people in a room, I would have confidence that there's 10 and there's 7. Both of those numbers are confident, and we call them significant. We know it's 17. Any number between 1 and 9 is significant. So in part A, all we do in this particular exercise, by the way, this is a measurement, so it's centimeters. This would be essentially the length of a large room. We would say that each of those digits is between 1 and 9, right? 4 is between 1 and 9, 4 is between 1 and 9, and 3 is between 1 and 9. So each of those would count as significant. So we would have 3 significant figures. That's all they're asking. How many significant figures are in that measurement? All of them are between 1 and 9. Now, when we get to B, there's an issue here in that there's a 0. And so for B, the issue is, 0 is not between 1 and 9, right? It's the one number that's not between 1 and 9. So how do we deal with 0? And here are the rules of 0. I'm just going to give you the first one. A 0 is considered captive if it's between two significant figures. So you see how that 0 there is between a 3 and a 3, and the 3's are significant? If it's in between, we call that captive, then it is also significant. Now, it doesn't matter how many significant figures are around that 0. As long as there's 1 on either side of it, it's significant. So in this case, there's 2 of them on either side of the 0, so that 0 is significant. Still captive. It doesn't matter how many captive 0s you have. As long as those 0s are surrounded by significant figures, meaning numbers between 1 and 9, then they're all significant. Every one of them is. And we count them all. Essentially what we're doing is we're counting powers of 10, right? This is the ones column, this is the tens column, and this is the hundreds column. You're essentially counting how many columns there are in that number. And they don't have to be right next to each other. See how the 0s are not next to each other, but they're all surrounded to the left and to the right by a number between 1 and 9. So these are all significant. Those are all called captive 0s. So again, all you're doing is you're counting the number of digits in the measurement. So for this one, there's a 1. Well, that's between 1 and 9. There's a 5. That's between 1 and 9. There's a 3. That's between 1 and 9. And then you have a 0. That 0 right there is captive 0, right? It's between a 5 and a 3. So that means it counts as significant. So this one has 4 significant figures. Now, the reason we're going through this will become apparent when we do further problems of calculations involving sig figs. So let's take a look at part C. Part C is a different situation. In part C, the 0 is not captive, right? It's the 0, there's actually two of them, right? It's an interesting thing. I'm not sure historically where this came about, but we often write a 0 in front of the decimal place. I think that's just to make it clear that there's a decimal coming after. I'm not sure why we do that. Be interesting to Google that and see the origins of that. But 0.0356 kilograms is the same as 0.0356 kilograms. So this is not a captive 0. It's not between, there's a 3 on the right, but there's nothing on the left. There's no number between 1 and 9 on the left. So this is what's called a leading 0. Leading zeros such as 0.021 or 0.13. These are not significant. Ever. Leading zeros are never considered significant. So for this one, the 3 is significant. That's between 1 and 9. The 5 is and the 6 is, but the 0 is not. So 3 significant figures. So notice we have two types of 0, if you want to think of it that way. We have the captive 0, which is significant, but the leading zeros are not significant. So we don't count them. Part D. In part D, we have a bunch of zeros. And these zeros are not in the front, they're not leading, and they're not in between, they're not captive. So we call these trailing zeros. Trailing meaning they're after the numbers between 1 and 9. Now here's the tricky part of this. If there's a decimal point in the measurement, then they're significant. If there's no decimal point, then it's unknown. We don't know whether they're significant. Okay? That's an important point. If a decimal point is shown, they are significant and they count. Doesn't matter how many are there. 1, 2, 3, 4, 5, 6, 7, 8. They all count. If there is no decimal point, we do not know. Okay? So let's take a look at this one. There is a decimal point, so they count. So that means all of them count, and that's 5 significant figures. Okay? Very simple. Those are the only 3 types of zeros: captive, leading, and trailing. So now we can move on to E. There's no more new ones to learn. 50 milliliters. See how there's a 0 at the end? That would be a trailing 0. There is no decimal point, so we don't know. So what we would have to say with this one, the 5 is definitely significant, is it either has 1 significant figure or 2 significant figures. We do not know. We just know it's 1 or 2. And then F is 0.9550. Is that centimeters? That's meters, sorry. Okay, well, the 9 and the 5 and the 5 are significant. It's the 0 on the right that's important, right? Remember, this could also be written as 0.9550. And so there is a decimal point. So the idea, the rule, that third rule is it's trailing. The trailing zeros are significant if there's a decimal point. So this one has 4 significant figures. Now I want to point out something about E that I forgot to tell you. If you wanted to tell people that the 0 was significant, one way to do that is just to put a decimal point after. Because remember, the rule for trailing is that if there's a decimal point, they're significant. So if I wrote that as 50 point, you'll see that in some of the Alex problems, this would be 2 significant figures. It gets rid of the ambiguity. There is, it turns out, a way to deal with it if you want it to be 1 significant figure, and that is to use scientific notation. Essentially what you do is, even though the decimal point is not shown, we assume it's right here. You move it 1 position to the left, and then you write it times 10 to the minus 1. So now it's 5 point, that's 1 significant figure, times 10 to the minus 1. And that's called scientific notation. That's a way to represent it with 1 sig fig.